Hello everyone. Today let's talk about this LeetCode problem 443 string compression. It says given an array of characters char, compress it using the following algorithm. So we have to begin with an empty string. If there are consecutive characters which are repeating, then uh, if the group length is 1, we can append the character itself to the string. If the group length is more than 1, it is followed by the character length. So if we have an array of characters like so. Okay, so the first criteria is we have to traverse the whole length of the string. If we find that there is just one character in a group, then the original array will the first element of the original array in this case will become A. We are not going to append the number of characters after that. And then if it's more than one, like here, B repeats itself twice. So the length of the group B is going to be 2. So we'll have A, then followed by B, and we will have 2 after that. And 2 will be written as a string. Okay, the compressed string should not be returned separately, but instead be stored in the input character array chars. Note that the group lengths are 10 or longer. Cannot will be split into multiple characters in char. So if C was like it kept going on and on, like say there are 14 C's over here. So what our array will look like is it's going to be it is not going to be one four in one character. It's going to be 1 and 4. um Okay, and after we are done modifying the array, we have the final return statement is going to be the new length of the compressed array. Okay, and the characters in the array beyond the return length do not matter and should be ignored. So so basically we are compressing the array in place. If a character appears multiple times in a row, I'm replacing it with the character followed by the count. And if that count is greater than 9, I am splitting the number into one character each. So one way of doing this is we can use another buffer string. We can create a buffer string which is going to take care of all these. Like it's going to traverse the entire string. It's going to look for groups. Say if it finds A, it's going to see if the next character is A, and then it's going to increment the group count. And if you have just one count of A, it's just going to put that character in place. And if it's more than one count, it is going to append that count to the array next to the character, say like it happened with B. But here we are creating a buffer string. So after the entire operation has been done, we are going to uh, copy that new string to the original chars array. This is not a good solution because it uses additional space in memory. So the space complexity is going to be O(n). So instead of that, what we can do is we can use the same character array and write in its start writing from the left as we go traversing the array, so that it does not occupy more space. The space complexity remains O1. So, so here, how I'm planning to solve this problem is taking the two-pointer approach. So I am going to have a read pointer and a write pointer, right? And the read pointer is going to traverse the array from left to right, uh, looking for potential matches and then incrementing the counter. And the write pointer is going to start writing and overwriting the array from left to right. We are not taking a new array to create our compressed string and then copy it back. Um, since the compressed version is always shorter than or equal to original, I don't have to worry about the write pointer overtaking the read pointer and overwriting data I haven't seen. Okay, so how do we start? We are initializing a read index and a write index. We will start off with a while loop, so which will iterate over the entire length of the string. Let me define a variable length, which is essentially the length of chars. So here, what we are doing here is we are going to be um, iterating the so the read index is the scout, right? It traverses through the entire array. So I'm going to take the read index through the entire array, and how far will it go? It is going till the length of the string. Okay. So let me plan out what I am going to do now. So the first thing is, okay, so initializing the pointers that I have already done. Initialize the pointers, iterate through the array with read index pointer. Then we are going to count, right? So how are we going to count? Okay, no, first find the end of the current character group. Okay. Next, we will write the character, and we will write the character to the given index. And if count is greater than 1, we are going to get the digit, uh, write the, and if count is greater than, write the digits, okay? Write the digits as well. As well. In the end, what do? We return the right index, that is the new length of the compressed string. Okay. So so first thing, finding the end of the character group. So let's say while read index is less than the length, less than the length, and okay, so characters, like chars of read index equals the character. Okay, so first we will take the char of read index here. Char is chars read index. We start off with count as 0. Now we are going through the entire array, right? First, the read index, when it is, say, read index is 0, right? So when the read index is 0, um, when the read index is 0, it is going to look for an character read index equal to char. Characters is the uh, array of 0 equal to a, right? Let's change this to a and try to find out what is going to happen next. Okay, so if characters 0 equal to a, and so we are defining the first character in the group here. This is the first character in the group. So you keep reading, right? And then if you find that this first character is equal to the read index that you are reading, okay, then what you are going to do is you are increasing counter by 1. And as you were reading through the array, you are also increasing the read index by 1. Okay, so now you have a in within this while loop, when read index is 1, we already had defined char as a at the top. So chars 1 is also a, right? Chars 1 is also a. So counter has incremented by 1. So counter becomes 1. Here counter becomes 2, right? So read index also, as you increase the counter, you are incrementing the read index as well. So read index has become 2. So the next iteration, when we will be moving to b. But before that, we need to write down the character at our location. So first, what we are going to do is we will write at the first location. Okay, we are going to write at the first location our uh, the character we have in our first group. Okay, we are going to increment the right index by 1. Okay, now what do? If count is greater than 1, we need to split the individual digits. So how do we do that? If count is greater than 1, we are going to iterate through each digit in the make that count a string. So each digit of that string, right? And each of that digits have to be written to the next right index. So chars of right index is going to be uh, assigned the value of digit, right? And again, we are going to increment the right index by 1. So essentially, what's happening? We have written now the char array has been overwritten, right? At this point, we have A, we increase the right index by 1, and then when we see that the count we got here was 2, then we don't need like this for loop is going to run just once, and the we have incremented right index by 1, so right index is at 1. So at this point it is going to go and write the digit, right, at this place, and it will be in the form of a string. So this inside of this loop is done. Inside of this loop is done, write has happened for this first group, and then we go to the next. So when we go to the next read index is already 2, right? So we are going to start reading from B. So when we start reading from B, let's not look at this at first. Let's go and write at so read index has incremented by 1, right? So at 2, we let's write B. Now, in this while loop, we are again checking whether this read index is still not overshooting the length of the array, and the character in the read index is equal to this character we have defined here. So before we start the while loop, I already said that we are going to take the first character of this group. So B, is B equal to B? Yes, so count increases by 1. So this while loop will go on and count B as 2 again. So right index has incremented by 1. So right index is at 3, and 2 will be written here, right? So after it has taken care of this new group of B, it moves forward to the third group, that is C. So beginning of the loop, we are again assigning char as C, and then count. We are starting over, right? Count is 0. While it's still not overshooting the length of the array, let's check if this read index, the scout that is going through the entire length of the array, is equal to the char that you defined right here. Is it equal? Yes. So you keep incrementing count, keep incrementing the read index. So we were assuming that the number of C's here was 14, right? So in the end, we are going to get count as 14. But before taking care of the number of digits, what we have to do is write at the last right index we had saved. And what do we write here? We write C. We increment the right index by 1. So right index is pointing here right now. And we have to make our second check. That is, if the count is greater than 1. Count is definitely greater than 1. We are going to iterate over this loop where each digit of 14 will be taken one by one for digit in string count. So we take 1, we write at char index, char right index 1, and then increment right index by 1. Then next we encounter the second digit, that is 4. So we write 4 here, and we are done. In the end of our entire ordeal, what do? Is we return the right index for the last position that we have written in this array. Um, we Why do we do this? Because the program, the problem wants us to return the size of the uh, compressed string, right? So let's comment out all our rough notes and let's run this problem. and it runs and it's accepted as well. So coming to the kind of complexity analysis, the time complexity is going to be ON. Even though I have nested loops here, the read pointer only ever moves forward from 0 to n. So each element is visited once, right? The read pointer goes from 0 to the length of the array. So each element is visited once, and the space complexity, as I already discussed before, is going to be O1 because I am modifying the input array directly and using only a few variables for counting. So let's brace ourselves for some interview questions that might be asked as a follow-up to this problem. So, what if the count is 1000 plus? How does that affect your space? Technically, converting the number to a string uses a tiny bit of space relative to the number of digits. Example, log 10n. However, in the context of big O, this is still considered O1 because the space doesn't scale linearly with the input size n. It's capped by the maximum value of an integer. So, what if the what if you're asked, how can you solve this without converting the count to a string? Yes, I could extract the digits manually by using the modulo operator, right? And getting the last digit. How do we get the last digit? Last last digit can be got by doing count modulo 10, right? And that, okay, while count last digit will be 10, count modulo 10, right? And you write that in the last digit into the right index. That is what we do. Okay. And I would store the digit, yeah. And then reverse them since the modulo gives them backward to me, right? So I can't just go about putting these last digits directly to the right position. I have to reverse the array. So we could do that as well. How would you handle this if the input was a linked list instead of an array? The logic remains similar, but in place modification is actually easier in some ways because I just can't delete nodes or change the next pointers. However, I wouldn't have random access to indices, so I would have to be very careful with my pointer references to ensure I don't lose the head of the list. Is this algorithm stable? In the context of this problem, yes. We process the string from left to right and the pointer moves from the pointer moves from left to right and we write from left to right. The relative order of the unique character groups is guaranteed to be preserved. What if you give an empty array? The outer while loop, if it's an empty array, the outer while loop won't execute and we return 0 as the right index. It handles it gracefully. Is there any risk of index out of bound error? No, because both the outer and inner while loops are guarded by uh, read less than length condition. This is very important. We cannot forget to put this in the code. How would you handle this if you couldn't use a string conversion for the count? So as I already discussed, we can put this as modulo and then put it in an array and store them in a temporary buffer and reverse it and assign to the right index. So that is it with this problem. Thank you for listening. Have a good day.